want to focus on the types of problems that you'd be doing on the assignment. So 10.4 covers writing equations of hyperbolas in standard form, finding asymptotes of and sketching hyperbolas. So the asymptotes, I'm going to give you the equations for them, but I'm not going to go over an example because it's not needed for the assignment. And then sketching, just use Desmos. So I'm not going to go over sketching. I will sketch when I go through some of these problems, but if you're given an equation, just put it into Desmos. Using properties of hyperbolas to solve real-life problems, so I am going to go over one of those, and then classify conics from their general equations. I'm not going to go over that part. That is like the last section in 10.4, and that's just good for reference, so you can take a look at that and like just print those out. But I'm going to be focusing on hyperbolas. So the definition of a hyperbola is that it is the set of all points for which the absolute value of the difference of the distances from two fixed points is constant. So a parabola, it's the sum. The hyperbola is the subtraction, so it's the difference. So that's the difference between the two, and that's their equations are very, very similar. The ellipse is the sum, and that has a plus in its equation. The hyperbola is the difference, so it has a minus in the equation. And because the hyperbola has subtraction, it does matter which order you write things. With the ellipse, it didn't matter whether you had x squared or y squared first, but it does matter with the hyperbola, so you want to be very careful of that. So the parts of a hyperbola, we have the center, where we always use h comma k to represent the center. A is the distance from the center to the vertex, and the vertex is a point on the hyperbola, on the curve, basically. C is the difference, or is the distance from the center to the foci, or the foci. So I always forget how to pronounce that, so I should label this. And your vertices and your foci based off of knowing the center. We don't really, the examples I picked up for today, we don't have to worry about that so much. So the standard form of a hyperbola, I mentioned that it has subtraction here. So you've got your x minus h squared over a squared minus y minus k squared over b squared. And then there is a different one based off if it's horizontal or vertical. When we have an ellipse, the change is where a squared is. For a hyperbola, the change is what is over the a squared. So that's the difference. It's not that a squared is always under, and then because of the subtraction, you have to have it in different orders. So, I mean, the a squared is either going to be under the x squared or the y squared portion based off of its horizontal and vertical, but those portions always have to be written first because of the subtraction. So you want to pay attention to that so that you don't accidentally use the wrong. And then here's the relationship again, that c squared is a squared plus b squared. And then what happens if it's at the origin. But these are the important equations, and you want to make sure that you're using the correct one, because if you aren't, that's where your errors usually occur. So when you're looking at this, when you have a horizontal versus the vertical, this is going to be a handy picture. I took this directly from the textbook so that you can remember which equation goes with which. So I'm going to keep referring to this because it's going to be very helpful. So we're going to just go straight into the examples. So example 1, find the standard form of the hyperbola with vertices plus or minus 4, 0 and foci at plus or minus 6, 0. So the first thing I always do is draw a picture because that helps me determine whether I have a horizontal or a vertical hyperbola. I'm just going to sketch. Then the foci are not touching the hyperbola. So where I have x minus h squared over a squared minus y minus k squared over b squared. So that's x minus h squared that are middle here. Oops. So the center is always going to be halfway between the vertices, and it will also be halfway between the foci. So it's going to be the middle point between both of those. And so based off of where our picture is and the fact that my picture is not drawn to scale, so it doesn't actually look like the halfway point, but the center is going to be at the origin. So that is the middle between all of my points here, between -4 and 4 and -6 and 6. So the center is 0, 0. So that means h and k are each going to be 0. So I know those. Now I need to determine a squared and b squared. And I always start by determining a squared. So if I go back to the parts of the hyperbola, a is the distance between the center and the vertex. So I can go ahead and label that. So this distance between the center and our vertex A, that is going to be A, which means I can get a squared, which is 16. And if I go back to my picture here, C is the distance from the center to one of the foci. So if I use that definition, that means the distance from 0 to 6, that's telling. So once you have A and C, then you can use the relationship that C squared is equal to A squared plus B squared. And we're going to use that to solve for B squared. So C is 6. So I have 6 squared equals, and then A is 4. So that's 4 squared plus B squared. 6 squared is 36. 4 squared is 16. Whoops. So I have 16 plus b squared. And so now I want to solve for b squared. So I'm going to subtract 16 from both sides. And I get 20 is equal to b squared. Now that I have b squared and I know a squared and I have my h and my k, I can give the equation. I can give the standard form. So I'm going to just plug my values into the equation. So we have x minus h. H is 0, so I can just write x squared over a squared, so 16, so that's 4 squared. K is 0, so that's going to be just y squared over 20, and then it's equal to 1. And then that is our standard form of the hyperbola based off of the information that they gave us. Do you have any questions? Okay. So moving on to my second example, we're going to find the standard form of the hyperbola with vertices 2, 3, and 2 comma negative 3, and then foci at 2 comma 6 and 2 comma negative 6. So I'm going to start by drawing my picture. Let's see. And because they're vertically aligned, that means I'm going to have a vertical hyperbola. And then the foci are going to be underneath, not. So the vertices are always hyperbola. Okay, so going back. Okay, so I have determined that I have a vertical hyperbola based off of the location of the vertices, because the vertices are vertically aligned with each other. And then I've mapped out where my foci are. So going back to the two different types of hyperbola, this is where the transverse axis is vertical. So that means I'm going to have the y portion first and then the x portion. So the y part is going to be over the a squared. The x part is going to be over the b squared. So my equation is going to be y minus k. Now k is the y value of the center, so that's going to move with it, over a squared, minus x minus h squared over b squared equals 1. So now I need to determine, I'm going to always start with the center. So the center is halfway between the vertices, and so that is going to be at 2 comma 0. So the halfway point between a y value of 3 and negative 3, that's going to be 0, and then our x value is not changing. So our center is 2 comma 0, or h comma k. So h is equal to 2, k is equal to 0. A is always the distance from the center to one of the vertices. So A is going to be 3 because there's a distance of 3 in either direction to a vertice. C is the distance from the center to one of the foci. So that distance, C, is equal to 6. So it's 6 in either direction to get to a foci. So we have A and we have C. So now we can find B, because C squared is equal to A squared plus B squared. So that's going to be 6 squared equals 3 squared plus B squared. So 6 squared is 36, and 3 squared is 9. So if 36 equals 9 plus B squared, and I need to solve for b squared. So 36 minus 9 is 27. So b squared is equal to 27. And once I have b squared, now I have all of the information that I need, because I know a squared and I know my center. So it's y minus k. K is 0. So it's just going to be y squared over a squared, which is 9, minus then x minus h, and h is 2, so that's going to be x minus 2 squared over b squared, which is 27, and then this equals 1. And that is our equation based off of this vertical hyperbola. Do you have any questions? Okay. Example 3, so this one's a little different. It says find the standard form of the hyperbola with vertices negative 2, 1 and 2, 1, and passes through the point 0, 5. I don't know why I wrote 0, 5, because in my notes, oops, what I wrote down on my piece of paper when I was solving this, I had 5, 4. So I'm not sure how I wrote 0, 5. It's supposed to be 5, 4. So I'm going to draw my picture and draw where my vertices are. So I have a vertice at -2, 1 and at 2, 1. So those are horizontally aligned. So that means this is a horizontal hyperbola. So I have those 2 points labeled, and then it also goes through 5, 4. So that is another point that is on our hyperbola. So this is horizontal, so my x term in my equation. So it's going to be x squared minus h squared over, or x minus h quantity squared over a squared minus y minus k squared over b squared equals 1. So first step is to determine the center. So that's going to be halfway between my 2 vertices. And this comes out to be 0, 1. So my center is the midpoint between the vertices. It's 0, 1, so that is giving me an h of 0 and a k of 1. Now I know A is the distance from the center to one of the vertices. So A is equal to 2. Now in order to find C, I would need to know a foci, but I don't have those. So I can't find C from where I'm at. So all I can do at this point is write what I know so far and put them in the equation. So in the equation we have x minus h, and h is 0, so that's going to give me x squared over a squared. So a is 2, so 2 squared is 4. Then I have y minus 1 because k is equal to 1, and then I don't know b squared. So what I need to do from here is plug in 5, 4 in for x and y so that I can solve and find b squared. So x is 5, so that's going to be 5 squared over 4 minus the y value in that second point that they give us is 4, so that's going to be 4 minus 1 squared over b squared equals 1. So I'm plugging in 5, 4, and this will allow me to solve for b squared so that I can get my equation. So 5 squared, I get 25 over 4 minus, and then 4 minus 1 is 3, and 3 squared is 9. So that's going to give me 9 over b squared equals 1. Now I'm solving for b squared, and I can multiply both sides by the common denominator to eliminate my fractions. So that would be mean multiplying by 4b squared on both sides. So multiplying by 4 will get rid of the denominator for the 25 over 4, and multiplying by b squared will get rid of the other denominator. So when I distribute 4b squared times 25 over 4, the 4's cancel, so I get 25b squared. Then 4b squared times the 9 over b squared. The b squareds cancel, so I have 4 times 9, which is 36. And then on the right, 1 times 4b squared is 4b squared. So now I'm going to solve for b squared. I subtract the 25b squared from both sides, so I can get the b squared all on one side. And I'm just going to kind of move up to the side here. And I'm going to switch to black so that it's a little bit easier to read when I go into the green. So that's a minus 36 equals 4 minus 25 is negative 21. So I have negative 21b squared. Now I'm solving for b squared. So I want to divide both sides by negative 21. The negatives cancel and I have 36 over 21. And I can divide 36 and 21 both by 3. So I can reduce that. So 36 divided by 3 gives me 12. 21 divided by 3 is 7. So I get b squared is equal to 12 over 7. So now that I have b squared, I can put that into my equation and I can get our standard form. So we have x squared over 4 minus y minus 1 squared over b squared. Now that would be 12 over 7 equals 1. And because we have a fraction in the denominator, that's the same as multiplying by the reciprocal. So that actually gets rewritten as 7 times y minus 1 squared over 12 in our equation. And now we have the standard form of this hyperbola. It was a little more work because they didn't give us the foci. We had to determine what we needed because they gave us a single point. Do you have any questions? Okay, so we have y minus 1 squared divided by 12 over 7. When you're dividing by a fraction, you're multiplying by the reciprocal. So that means we're multiplying by 7 over 12. So y minus 1 squared times 7 over 12 means that you're multiplying the 7 by the y minus 1 squared, and then your denominator is now 12 because you're multiplying by 7 over 12. So that's how we get the 7 over 12, and it's now 7 times y minus 1 squared over 12. So dividing by a fraction is multiplying by the reciprocal. Does that clarify that? Okay. Any other questions? Okay. Now the last example that I have here, if I can get it to pull up. This is a word problem. It's similar to what you have to do on the application assignment. So we have listening station A and listening station B are located at 3300 0 and negative 3300 0 respectively. Station A detects an explosion 4 seconds before station B. Assume the coordinate system is measured in feet and the sound travels at 1100 feet per second. So we have two questions here. Where did the explosion occur? And then station C is located at 3300, 1100 and detects the explosion 1 second after station A. Find the coordinates of the explosion. So we cannot find the exact location of the explosion until we have the information from station 3, because you need 3 points in order to get the exact coordinates. For part A, which is basically as much as you're asked to do on the application assignment, you can't figure out the exact location, so you have to describe where it is. So to do a problem like this, first I'm going to draw my picture. So I have 3300 0, so that is station A. And then station B is at negative 3300 0. So those are, when we're given information like this, the explosion is not at the station, so that means that these are not on the hyperbola, these are the foci. So these are going to be the foci. We don't actually know where the vertices are. All we know in this case are the foci. And these are horizontal, so our equation, we're going to use the horizontal equation, x minus h squared over a squared minus y minus k squared over b squared equals 1. So based off of these points, because they're giving us the foci, we don't know A, but we know C. C is the distance from the center, which you can see here is 0, 0, and then one of the listening posts. So that's going to be 3,300. And HK here is equal to 0, 0. So we know C, and we know a center, but in order to get our equation, we need to figure out a squared and b squared, so we need to figure out a and b. The only way to figure out b is in terms of c and a, so we need to figure out a. This is where we need to use the information that they're detecting the explosion 4 seconds before station B. So that is telling us it took 4 seconds to travel from station B to A. So this distance took 4 seconds. And so we can determine how far that distance is. Well, we know how far that distance is. That's 3,300 times 2. But let's see, the system is detecting it on the hyperbola. So really, this 4 seconds is telling us where the vertices are, because we're detecting that it's on the hyperbola. There we go. And so the distance between those two, so it's giving us the distance between our vertices, which we don't know. So that is the distance that it goes in 4 seconds. So if it takes 4 seconds, and we know that sound travels at 1,100 feet per second, we're basically doing a unit conversion here, and this gives us that it is 4,400 feet between the vertices. So that means it's half of that to get to one vertice. So half of 4,400 is 2,200. So this gives us that A is equal to 2,200. So we had to use the fact that they tell us the explosion, that A hears it or detects it along their little hyperbola 4 seconds before B. And then we use that to convert it to feet, knowing the speed of sound. And then half of that will give us the distance from one vertice to the center, which is 2,200, and that's A. So now we know A, and we know C. We need to use those to solve for B. So I'm going to go into my next screen here. So C squared is equal to A squared plus B squared. So C was 3,300 and A is 2,200, half of that distance. So I have 3,300 equals 2,200 plus B squared. So I need to get a calculator and I need to square these numbers. So when you square 3,300, we get 1,089,000. So that is 10,890,000. When you square 2,200, I got 4,840,000. So that's 4,840,000. Then plus B squared. So I need to solve for B squared. So I'm subtracting the 4 million-ish number. When you do that on your calculator, you get 605,000,000, which is 6,050,000 is equal to b squared. So now this gives us an equation, because now we have our b squared, we know our a squared, we know our center, which is at 0, 0. So we have x squared over a squared, which is 2200 squared, minus y squared over b squared. So if I want to write these full numbers, I need much longer. So this will be 4, 8, 4, 0, 0, 0, 0. Y squared is under over b squared, which we just solved for, 605,000,000 is equal to 1. And so we have an equation for our hyperbola. And so the question going back here, where did the explosion occur? Well, we know it's on that hyperbola. And because A detected the explosion before B, it needs to be on the right branch. So we don't know the exact location. All we know is that it's on the right side because that's closer to A. So the explosion occurred on the right branch of, and then our equation. So we don't know the exact location, we just know that it occurred somewhere on the right side of that equation. So are there any questions on part A and how I got those values? Okay. That's about as much as you need to do on the application assignment for the lightning problem. Now, this particular problem also gives us more information. For part B, it says station C is located at 3300, 1100. So that's going to be somewhere here. We'll call that station C. And it detects the explosion 1 second after station A. Find the coordinates of the explosion. So if it's detecting it after, let's say we have another kind of hyperbola here, and then it's going to be looking like here. We're kind of looking for where are they intersecting in a way. We're looking for where the explosion probably happened somewhere in this area. And it's got to be on our original line. So it's going to be somewhere on this part that I have shaded in. In order to do this problem, we're going to assume that these are vertical in line. So we're going to assume that it's going to happen where my x value is equal to 3300. So we're going to make that assumption that these are all, that it's going to happen vertically. Now, I don't have a very vertical picture here, but we're going to assume they all have the same x value. Because C is basically straight up from A, and so that's how we're going to determine where this coordinate is happening. Another way to think about why we're setting that x value to equal to be 3300 is that C detects it 1 station after, or 1 second after A. So 1 second times our speed of sound, 1100 feet per second, gives us 1100 feet. And that's also equal to the same distance from C to A. So that is also equal to 1100 feet. So we're going to assume that, okay, then they must be in line with each other in order to get to where the explosion occurred, because if they weren't in line, let's say the explosion was somewhere at an angle, then that distance from C to A would not be the same as the difference from where A hit it and B hit it. It would actually be longer. This is actually sort of looking at some geometry here, that this distance that I'm kind of shading in, unless they got really lucky, that distance from C to the same sort of place where A would be would not be equal to the exact same distance from C to A. So because they are the same distance, we're going to assume that these are all in a straight line. So that means the X value is going to be 3,300 for wherever this explosion occurred. So that means to find the coordinate, we plug that into our equation so that we can find the Y value. So our equation has X squared, so that's going to be 3,300 squared. And then we have 484,000 minus Y squared, and that was 605,000 equals 1. And now we need to solve this for Y. If on your calculator you do 3,300 squared and then divide it by 484,000, that comes out to 2.25. That's just going to make my life easier if I don't write that as a fraction. We can, it's actually a pretty easy fraction, but I just divided that. Now, in order to solve for Y squared, I can eliminate my denominator by multiplying both sides by 605,000. It doesn't want to. For some reason, sometimes on this left side, it doesn't like me writing all the numbers. There we go. So that means I'm also going to multiply the right side by 605,000. So I'm multiplying by the denominator so that I can get rid of that fraction. When you do that, 2.25 times 605,000, you get 1361250. The denominator cancels, so that's minus Y squared, and then equals 605,000. So I need to solve for Y squared, so I'm going to subtract from both sides 1361250. And oh, I was hoping I had another slide here. Nope, I did not give myself enough room, so I'm going to move that over here. So we get negative Y squared equals, when you do your subtraction, we get negative 7562500. So now I'm going to divide both sides by -1 so that I get Y squared equals a positive 7562500. To solve for Y, we need to take the square root of both sides. So I'm going to take the square root of Y squared and the square root of that number. And when we take the square root, we get a plus or minus. And that actually comes out to a nice number, 2750. Now, based off of our picture, because it took longer to get to C than to A, it's going to be below, so it's going to be the negative version. It's going to be on the bottom. If I go back to my original picture here, it's on the bottom part because it took longer to get to C than to A. So that's going to be, I'm going to use the negative coordinates. So the coordinate then is going to be 3,300 negative 275. 0.50. And then that's giving us the coordinate of where the explosion occurred. We have the exact information because we had a third point. We can determine that. Do you have any questions? UTA, what is UTAMMS? I'm not familiar with that acronym. Triangulates enemy fire with 3 to 4 microphones. Okay. Yeah. So this is like a real world application. Of course, you know, we're making a lot of assumptions here. Is my screen sharing, did that disappear? Or is that still showing up? Because I got a notice that said that I had some problems with video. That's still there. Okay. Good to know. Okay, so this brings me to my last slide, which were the asymptotes of a hyperbola. So they're angled. They're basically equations of the lines. They talk about the conjugate axis, where if you have a horizontal, then the conjugate axis would be vertical. And then there's the equations here. So it's the same sort of thing. You need to know H and K, and you need to know A and B. So we know how to find A and B. We've gone through plenty of examples with that. So once you've figured out what those are, and if you're given the equation, you can find those pretty easily. Then you just plug that into the equation here. And there's a plus or minus because there are two asymptotes, one with a positive slope and one with a negative slope. So your slope is this B over A part or the A over B, depending on if it's a vertical or a horizontal. And then you have a y-intercept based off of multiplying that out. So there's two asymptotes, so the plus version and a negative version. But you don't really need that for the assignment at all. So just have that as a reference so that you can plug in numbers there if you need to. And that was everything that I had planned. I knew that I needed to do an example similar to that lightning problem, so I wanted to make sure that I got that in.